we get 2g is equal to -2, 2f is equal to 3, and you get c is equal to k. Therefore, what is the radius? Let's find g first. G is equal to -1. You get f is equal to 3 by 2, and you get c is equal to k. So therefore, radius r is equal to root over of
Still,
g square plus f square minus c. Which is equal to root over of g square plus f square minus c. Yes, so you get here let's simplify this a little. 1 plus 9 by 4 minus k equal to root over of, take the LCM, get 4 plus 9 minus 4k by k, which is equal to root over of 13 minus 4k by k. This is the radius. And what is the radius given? 2.5 units. So this 13 minus 4k divided by k must be equal to 2.5. Okay, so you can solve for k here. Root over of 13 minus 4k divided by k is equal to 5 by 2. Square both sides to remove the radical. You get 13 minus 4k by k is equal to 25 by 4. Okay. Now you can solve this equation to get k is equal to -3. Okay, so that solves the first part of the question. Also, since the equation of the circle is given, you can find out the center of the circle also. It's minus g minus f, which is equal to minus g means change the sign of g, and minus f means change the sign of f. F here we have got 3 by 2. So the center of the circle, y coordinate is -3 by 2. Okay, so that finishes the first part of the question. The second part is find the equation of the diameter of the circle which passes through the point 5, 2.5. Okay, so this is your circle with center. C coordinates we have found above, 1 minus 3 by 2. You have to find the diameter of the circle. Let's say this is the diameter. Which passes through the point 5, 2.5. Let's say passes through this point 5, 2.5. So what should be the equation of the diameter? You can use 2-point form, right? So the diameter passes through C, center, 1 minus 3 by 2, and the other point is 5, 2.5. 2.5 can be written as 5 by 2. Now you can write down the equation of a straight line by 2-point form. Therefore, equation of the diameter is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, so you get y plus 3 by 2 is equal to 5 by 2 plus 3 by 2 will simply give you a 4. And in the denominator you have 5 minus 1, 4, x minus 1. So this cancels here. So you can now find out the equation of the diameter to be 2x minus 2y minus 5 is equal to 0. Okay, so this was an easy enough question. We can move on to the next problem then.
Yes, sir.
Problem number 4. Prove that the circle touches the x-axis. This is the first question. Second question is lies entirely inside the circle. X square plus y square is equal to 18. Okay, so let's write the given equation of the circle. First equation given here is x square plus y square minus 6x minus 2y plus 9 is equal to 0. Let's call it 1. And the second equation given to you is x square plus y square is equal to 18. Let's call this number 2. You need to show that circle 1 touches the x-axis. Okay, so because the equation of the circle is given, we can find out the center and the radius. So let's first find out the center and the radius. So comparing 1 with the general form. We get 2g is equal to minus 6, get 2f is equal to minus 2, and you get c is equal to 9. That means you get g is equal to minus 3, you get f is equal to minus 1, and you get c is equal to 9. So therefore radius of the circle 1 is r is equal to root over of g square plus f square minus c, which is equal to root over of minus 3 square minus 1 square minus c. Okay, so this is root over of 9 plus 1 minus 9, which is equal to 1 unit. Right? So radius of the circle 1 is 1 unit. And what is the center of this circle? Minus g minus f. Change the sign of g and f. 3, 1. This is the center of the circle. Okay. Now the first question is you need to show that it touches the x-axis. Now if the straight line touches the x-axis, what happens? If you remember, I told you, what do you need to show? If this circle touches the x-axis, suppose, then what do you need to show? Center here, you know, is 3, 1. Right? So what should the radius be equal to? Radius should be equal to the y coordinate, right? 1 unit. So radius of the circle is equal to y coordinate of the center, which must be equal to 1 unit. And we have already shown that the radius is equal to 1 unit, which is equal to r. Hence, we say that the circle touches the x-axis. Right? That finishes the first part. What about the next part? We need to show that this circle is inside this circle. That is, the circle 1 is inside the circle 2. Okay. So if you first write down the center and radius of circle 2. So what is the center of circle 2? Is the origin, right? Because it is of the form x square plus y square is equal to a square. And what is the radius? Radius is equal to See, this right hand side is 18. It is equal to a square, right? Which is equal to root 18, right? Any question here?
No, sir.
Which is equal to 3 root 2 units. Okay. Now you need to show that this circle here, circle 1, is inside the circle 2. How do you show? If one circle is inside the other, let's say this way. One circle is inside the other. It would suffice to show that if I can say that the radius of this circle and the radius of the bigger circle, say this, the radius of, if it would suffice to show that one radius is greater than the other, right? Also, what do you have to show? It would suffice to show now radius of circle 1. Let's write it, radius of circle 1 is r is equal to 1 unit. We have found out above, right? And what is the radius of circle 2? Is a is equal to 3 root 2 units. So which one is greater? Here a is greater than r, right? So this means that the radius of the bigger circle is smaller than this other circle. And what else can we show? What else to show? Can you tell me what else to show? Apart from this, if one circle is inside the other, we have already stated that the radius of the bigger circle is greater than the smaller circle. Can you say what is the other point that we must show to conclusively say that it is inside the other? Because it is quite possible that the radius of one circle can always be greater than the other circle. That's no problem. You can have two isolated circles also. You can have two isolated circles, one radius greater than the other. But how will I show that this particular smaller circle is inside this circle? Any idea? You can show that the distance between the centers is less than the radius of the bigger circle. Then only we can say that the one circle is inside the other, right or wrong?
Right, sir.
If we can show that this distance here is less than the radius of the bigger circle. So let's find out the distance between the centers. Distance between the centers. What are the centers here we have determined? The first center was 3, 1. And the other center was 0, 0. Is root over of, by distance formula, 3 minus 0 square plus 1 minus 0 square, which is equal to square root of 3 square plus 1 square, which is equal to root 10 units, right? And radius of circle 2 a is equal to 3 root 2 units, right? So clearly we can say that the distance between the centers is less than the radius, right? Hence, circle 1 lies inside circle 2. Okay, so we have two things to show. First of all, that the radius is of one circle is greater than the other. And what was the other thing that we showed? That the distance between the centers is less than the radius of one of the circles, right? Okay, so we can move on to the next question now.
Yes, sir.
Number 5. The question here is find the equation of the circle whose center is the point 4, 5 and which touches the x-axis. Okay. Also find the coordinates of the points at which the circle cuts the y-axis. Okay. So the what is the given center here? Center of the circle is 4, 5. Now, if this circle touches the you have to find the equation of the circle whose center is this and it touches the x-axis. Now, if a circle touches the x-axis, then what happens? As I told you earlier also, that if it touches the x-axis, then if the center is 4, 5, then what should the radius be equal to? Radius should be equal to the y coordinate, right? So radius of the
Yes,
circle
sir.
is equal to 5 units. Is equal to, let's say, y coordinate of the center is equal to 5 units. Reason is since the circle touches the x-axis. Therefore, what is the required equation of the circle? From your standard form, x minus h whole square plus y minus k whole square is equal to r square. Radius is 5 units. Okay, so this is the required equation of the circle. You write this in general form, or you may not write it in general form also. It's no problem. Okay, in order to answer the second question, it is not actually required to write this equation in general form. Okay, so let's attempt the question as it is. Also find the coordinates of the point at which the circle cuts the y-axis. So at what point will this circle cut the y-axis? Putting y-axis means x is equal to 0, we have to put, right? We get 0 minus 4 square plus y minus 5 square is equal to 5 square. Now you will get a quadratic here. Just write it here. You have 16 plus y minus 5 square is equal to 25. Instead of getting a quadratic, you can solve this very easily. Instead of actually expanding y minus 5 whole square, you can write this as y minus 5 whole square is equal to 25 minus 16. That means y minus 5 whole square is equal to 9. That means you get y minus 5 is equal to plus or minus 3. That means either y minus 5 is equal to plus 3 or y minus 5 is equal to minus 3. That means either y is equal to 8 or y is equal to 5 minus 3, which is 2. So the roots of this quadratic is 8, 2. So therefore, what is the point at which the circle cuts the y-axis? Therefore, the circle cuts the y-axis at 0, 8 and 0, 2. Clear?
Yes, sir.
Any question?
No, sir.
Number 6 we'll do. Number 6. Prove that the circles touch at the point 3 minus 1. Okay, now see here, this is a strange question in the sense that they have simply said touch this. Now we don't know whether we are required to show whether they touch internally or externally. That we have to determine. Now before attempting this question, if you remember in class 10, I told you if two circles touch each other externally, then what happens? That the distance between the centers must be equal to sum of the radii, right? or let's say C1, C2. If the center here we call C1 and C2, then the distance between the centers, which we can find by distance formula, if we know the coordinates of the center, if we can show it is equal to sum of the radii, we can say that the circles touch each other externally. In case of internal touching, what happens? If this circle touch each other internally, then what happens? If you have C1 and C2 as your centers, then the distance between the centers must be equal to difference of the radii, right? That is R1 minus R2 or R2 minus R1. Sometimes this is also expressed as plus or minus R1 minus R2, right? This is what I told you, if you remember, back in class 10. So here we have
Yes,
to
sir.
show that the circles touch each other, but we don't know whether internally or externally. So what we need to show here is that the distance between the centers is either equal to sum of the radii. If you can show it is equal to sum of the radii, then you will say they touch each other externally. If you can show that it is equal to difference of the radii, R1 minus R2 or R2 minus R1, then you can say that the circles touch each other internally. Okay, so let's show this. Write down the equation of the circles first. The given equations of the circles are x square plus y square minus 4x plus 6y plus 8 is equal to 0. Call this 1, and the other one x square plus y square minus 10x minus 6y plus 14. These two are the equations given. Our first duty is to find out the centers and the radii of both the circles. Okay, so comparing 1 with x square plus y square, standard form, to g1x. Why g1x? Because there are two circles given, so we'll denote the coefficients by g1 and g2. Twice f1y plus c1 is equal to 0. We get 2g1 is equal to minus 4. 2f1 is equal to 6. And we get c1 is equal to 8. So that means we get g1 is equal to minus 2. f1 is equal to 3. And you get c1 is equal to 8. So therefore, coordinates of the center of 1 is c1 minus g1 minus f1, right? Which is equal to c1. Change the sign of g1 and f1. You get 2 and minus 3. This is the coordinates of the center of first circle. And also find out the radius. Radius of 1. Let's call it r1 is equal to root over of g1 square plus f1 square minus c. Put the values. Root over of g1 square plus f1 square minus c. Okay. So you will get the radius r1 as root 5 units. So 1 is complete. Similarly, we do with the second one also. So comparing 2 with x square plus y square plus twice g2x plus twice f2y plus c2 is equal to 0. We get 2g2 is equal to, if you see the coefficient of x here is minus 10, twice f2 is equal to minus 6, and you get c2 is equal to 14. So you get g2 is equal to minus 5, f2 is equal to minus 3, and you get c2 is equal to 14. So therefore, coordinates of the center of 1 is, let's say, c2 minus g2 minus f2, which is equal to c2. Change the sign of g2 and f2, you get 5, 3, right? And radius of 2 is R2 is equal to root over of G2 square plus F2 square minus C2, which is equal to root over of G2 square minus 5 square plus minus 3 square minus 14. Okay. So you get radius of this as root 20, which is equal to 2 root 5 units. Right? Fine. Now we have got the coordinates of the center and centers of both the circles, and we know the radii of both the circles. We just now need to show that the distance between the centers is either equal to sum of the radii or the difference of the radii. So let's find out the distance between the centers. Distance between the centers C1, C2 is equal to root over of. Now what are the coordinates of the centers here? Coordinates of the centers here 2, minus 3 and 5, 3. Distance between these 2 points. Right? By distance formula, it is 5 minus 2 whole square plus 3 plus 3 whole square. Right? Which is equal to root 45. Now root 45 is equal to 3 root 5 units. Okay. So now you see that the distance between the centers is 3 root 5. Also the radii here are root 5 and 2 root 5. If you add the 2, will you get 3 root 5? R1 plus R2? Yes, 2 root
Yes,
5
sir.
plus root 5 is 3 root 5. So we see here, we see that C1, C2 is equal to R1 plus R2 is equal to 3 root 5 units. Hence, what can we say, externally or internally?
Externally.
Externally. Hence the circles touch each other externally. Okay, that's it. You just have to show that the circles touch each other, and we have shown that the circles touch each other externally. Fine. Let's move on to the next question. Number 7. If you see the question said, find the equation of the circle which passes through, and 3 points are given, P, Q, and R. Okay. Find also, and then you have the other questions. Now, whenever you get this kind of a question, find the equation of the circle which passes through 3 points. Okay. 3 points minimum. On a minimum, you need 3 points to draw a circle. So therefore, if you get this kind of a question, this is the way you are going to attempt. Okay. You'll start by saying, let the equation of the circle be. Let the equation of the circle through P, Q, and R be x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay, let us call this 1. Now you have 3 coordinates given. So since 1 passes through, P10, it must satisfy the equation. So you put x is equal to 1 and y is equal to 0 in 1. So therefore 1 square plus 0 square plus 2g into 1 plus 2f into 0 plus c is equal to 0. Okay, so you get here 2g plus c is equal to minus 1. Call this number 2. Okay. Now also, since 1 passes through this next point q, three 0, put x is equal to 3 and put y is equal to 0. That means here you get 6g plus c is equal to minus 9. Call this equation number 3. Okay. Also, it passes through R. The coordinates of R given here are 0, 2. So put x is equal to 0 and y is equal to 2 in 1. So you get 0 square plus 2 square plus 2g into 0 plus 2f into 2 plus c is equal to 0. So you get 4f plus c is equal to minus 4. Call this 4. Okay, now you have three equations, 2, 3, and 4. This is there are three unknowns, g, f, and c, and you have three equations. So definitely you can solve these three equations. Okay, so how do you solve these three equations? Look at these two equations. These two equations are simultaneous equations in g and c, which you can obviously solve by elimination method. So solving 2, 3, and 4. We have, consider the first two equations, 2 and 3. So you get 6g plus c is equal to minus 9, and you have 2g plus c is equal to minus 1. Okay. Elimination method, subtract. This cancels. So you get 4g is equal to minus 8. That means you get g is equal to minus 2. So you've got the value of g. Now how do you get the value of c? Put the value of g in any one of the equation. Let us put in 2. So from 2, twice g plus c is equal to minus 1. That means c is equal to 4 minus 1, which is equal to 3. So we have got the value of g and c. How to get the value of f? Put the value of c in 4. From 4, 2f plus c is equal to minus 4. So you get here 2f is equal to minus 7, right? This you get 4f, sorry, this is 4f, not 2f. And this is also 4f. So you get here f is equal to minus 7 by 4. So you have got the value of g, f, and c. Hence required equation of the circle through the points p, q, and r of the circle through the points p, q, and r is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay, so now this becomes x square plus y square minus 4x minus can cancel here. You get minus 7y by 2 plus 3 is equal to 0. So now you can take the LCM. You get 2x square plus 2y square minus 8x minus 7y plus 6 is equal to 0. This is the required equation of the circle. Clear?
Yes, sir.
I'll stop here. The two parts of the question are left, which I will finish in the next class.